Good morning everyone, myself Ishika from BSc Chemistry Honours final year. Today I'll read about uses of organic and inorganic reagents in inorganic analysis. Reagents are those compounds which are used in inorganic analysis for the detection and determination of ions and molecules. A large number of organic as well as inorganic reagents have been used for this purpose. The inorganic precipitating reagents generally precipitate the inorganic species as sparingly soluble salt or hydrous oxide. The organic precipitating agents from sparingly soluble products either through coordinate linkage or through ionic linkage between the inorganic species and the organic precipitating reagent. Advantages of using organic reagents. The advantages of using organic reagents are listed below. They are more specific than conventional reagents under certain conditions. Because of this property, they can frequently be used to detect a single type of ion in a complex mixture. They can be more sensitive. Classical semi-micro methods of qualitative analysis will usually not detect much less than 1000 gammas of a substance under specific test solutions. Organic reagents, on the other hand, are capable of detecting below 10 gamma and in certain cases as little as 10 to the power minus 3 gamma. They can be adopted in quantitative analysis. The organic precipitates are generally insoluble in water at a given pH and can be separated, dried, and weighed. Those reactions giving colored soluble products frequently shows a regular change in color intensity with concentration of the substance under test and so are adaptable to an accurate comparison with colors representing concentration. This is the basic idea in the branch of calorimeter. Common properties of organic reagents. Some of the common properties of organic reagents due to which these are used in inorganic analysis are given below. First, formation of colored precipitate. Organic reagents form direct characteristic color with the ions to be detected. For locating endpoint, that is as indicators employed in volumetric titrations. Formation of precipitate due to difference in solubility. This may be made on the basis of a gravimetric method. Extraction in organic solvent at controlled pH making reagents. This increases the selectivity of reagents. Difference in volatility. Oxidation or reduction to other valency state. Wash liquids. The chemical nature of the organic reagents is important in determining the use of above mentioned properties. Advantages of organic reagents over inorganic reagents. It is due to the following properties that they are better precipitating reagents than inorganic reagents. Selectivity. In many cases, organic reagents are somewhat specific. For example, cobalt from nickel using alpha nitroso beta nephthol or dimethyl glycoxamine, aluminium from iron using cuprion, cadmium from copper using acid, and thiourea can be precipitated. In some cases, adjustment of the pH will often cause precipitation of one constituent alone. By changing pH and solvent conditions, one constituent after another can sometimes be quickly precipitated out. Ease of drying. Organic reagents produce compounds that have little affinity for water and are dried easily at temperature low enough to prevent decomposition. Co-precipitation. Lack of ionic character of organic precipitation products greatly reduces co-precipitation in most cases. For example, the co-precipitation of sodium and potassium with magnesium is much less when the latter is precipitated by 8-hydroxyquinoline than when it is precipitated by phosphate or oxalate. Some exceptions in metals do occur. It has been little studied, but in some cases it is as bad as in inorganic precipitant. Reagents are usually insoluble in water, therefore, it is important not to add an excess of reagent. This is difficult because there is no way to tell when sufficient reagent without excess has been added. Any excess that is insoluble would add to the weight of the precipitate. Disadvantage of organic reagents. There are unfortunately disadvantages of using organic reagents. Volatility. This is the first practical disadvantage of organic reagents because chelated compounds are non-polar. The forces between individual molecules in the crystal are not very great. Thus, some of the metallic complexes which are precipitated in analytical chemistry are appreciably volatile above 130 to 150 degrees Celsius and most decompose above this temperature. Therefore, the drying of precipitate should be done below 130 degrees Celsius to avoid decomposition. Impurities in reagent. It is very difficult to prepare an organic reagent of the same degree of purity as, say, inorganic compounds. Impurities present in organic reagents may enter into the precipitate during the precipitation and cause undesirable reaction. For example, dimethylglycoxyamine exists in three forms, that is alpha, beta, gamma. Of these, only the alpha form is specific for nickel while preparing dimethylglycoxyamine. Gamma form is also formed along with the alpha form. If the precipitation is carried out with this impure dimethylglycoxyamine, then nickel will be precipitated with some other metals form because alpha form is specific for nickel, whereas gamma form can precipitate other metals also. B. Ketoenol isomerism in such compounds as dithiazone will cause errors in calorimetric work unless conditions are carefully selected. Low solubility of the reagents in water. This is the greatest disadvantage which organic precipitants have in comparison with organic precipitants. High molecular weight. The very high molecular weight of chelate complexes formed with metal ions reduce proportionality. Small errors in precipitation and weighing. Colored compounds. Chelated compounds are often highly colored, and since they are usually soluble in organic solvents, they lend themselves to calorimetric or photometric methods of analysis. Solubility in organic solvents. Because of their covalent nature, most metal complexes with organic reagents are soluble in non-polar solvents, chloroform being usually the best. Such solvents are used to extract the complex for calorimetric determination, or they may be used simply for separating one element from another. Thus, the complex of cupriferon with tripositive iron is very soluble in either and chloroform, which allow one to remove large amounts of ions from solution containing aluminium. In these extractions, the pH must be carefully adjusted to give the desired separation. Important organic reagents. Some of the organic reagents which are generally used in the identification of ions are discussed below. Oxine C9H7ON. The structure of this reagent is given in the figure. It is almost a colorless solid soluble in organic solvents and mineral acid. It gives yellow color, which may be due to formation of quinoid structure. It was introduced by Helm and Berg in 1927 as an analytical reagent. A number of metals give coordination complexes with this reagent. So, examples of such metals are magnesium, zinc, copper, cadmium, lead, aluminium, iron, boron, gallium, thorium, zirconium, etc. The formation of the complex compound with a bivalent metal ion like Zn2 positive is shown below. The quantitative estimation of the complex is carried out by drying and weighing the hydrated or anhydrous complex, or complex is ignited to oxide and then weighed. In volumetric method, the precipitate is dissolved by filtrating with hydrochloric acid, and then resulting solution is titrated against standard potassium bromate bromide solution. In spectrophotometric method, the estimation of the metal ion is carried out by measuring the optical density of the complex. The reagent has been found to be suitable for magnesium, aluminum, etc. The reagent is 2% solution of oxide in 2N acetic acid. Second, glyoxime. This reagent was discovered by L. Tishankov and was applied by O. Brunk For the determination of nickel in steel, the structure of this reagent is shown in the figure. This reagent gives an insoluble red gelate with Ni2 positive ion in ammonical medium. For detailed see applications of formation of chelated complex discussed in chapter on basic concepts of coordination chemistry. Solution of palladium salt gives characteristic Solution of palladium salt give characteristic yellow precipitate in dilute HCl or H2SO4, but nitrate ions interfere. Solutions of bismuth salt also gives a yellow precipitate in presence of EDTA at pH 11 to 11.5. For the studies of for the studies 1% solution of dimethylglyoxime in alcohol is employed. In spectrophotometric method, the insoluble precipitate is extracted into chloroform which yields yellow coloration, and then the optical density is measured. Alpha nitroso beta nephthol, also called 1-nitroso 2-nephthol. The structure of this reagent is shown in the figure. It is an orange brown powder having melting point of 109 degrees Celsius, soluble in organic solvents but almost insoluble in water. The reagent is usually employed as a saturated solution in 50% acetic acid. This reagent is common for precipitation of many metallic radicals, but it is used specially for the detection of ferric iron, copper, and cobalt with palladium and uranyl salts in slightly acid solution. It gives insoluble colored compounds under suitable conditions. Nickel and magnesium, however, are not precipitated by this reagent. Therefore, the reagent in acid solution is used for the separation of nickel from cobalt. The structure of the chelated complex formed by this reagent with CO3 positive ion is shown in the figure. The reagent also has been used for spectrophotometric determination of cobalt and few other metal ions. It is also used for spot test of cobalt. Fourth, cupferon. Cupferon exists largely not in the nitroso-hydroxy form but in the tautomeric amine oxide form. The reagent is usually employed as a 6% aqueous solution but is most useful in strongly acidic solution. In strongly acidic solution, it precipitates FeCe, NbTA, WGA, SnCu, etc. Precipitate should be filtered immediately after their formation because cupferon is not very stable in acid solutions. Furthermore, precipitation should be carried out in cold. Since the reagent is decomposed into nitrobenzene on heating, the precipitate cannot be weighed after drying but must be ignited to the corresponding oxide and then weighed. The formation of chelated complex with copper ion is shown in the figure. Fifth is aluminone. It is ammonium salt of urine tricarboxylic acid. Its structure is shown in figure. It is a brownish red powder freely soluble in water. It forms brilliant colored lakes with certain metals, especially aluminium, with which it gives a bright red lake. Aluminium is a dye and it is very important reagent for spectrophotometric determination of aluminium. By adjusting pH of the test solution below 7.8, it is possible to estimate 0.005 mg of aluminium even in the presence of calcium. The reagent is prepared by dissolving 0.1 gram of substance in 100 ml of water. Sixth is rubinic acid, also called dithioxamide. This reagent is the diamide of dithioxalic acid and is in equilibrium mixture with its tautomeric Sc diimido form. The Sc form combines with nickel, cobalt, and copper to give colored water insoluble inner complex salts whose composition is shown. The copper, cobalt, and nickel compounds are quantitatively precipitated from strongly ammonical solutions in strong mineral acid solutions. Rubinic acid reacts only with certain elements of platinum salts. In addition to above, rubenic acid forms colored compounds with silver, mercury, bismuth, and iron. Rubenic acid is not only important as spot test reagent but also and spectrophotometric reagent. Seventh is rhodamine B. It is tetraethyl rhodamine and is represented by the structure in the figure. Solutions of antimony salts in strong hydrochloric acid react with rhodamine B, and the aqueous solution of the reagent changes from red to violet or blue, and finally divided precipitate separates immediately and on after standing. Trace amounts of antimony may be detected in the presence of large quantities of tin by means of this reagent. Small amounts of iron do not interfere. Mercury, gold, palladium are precipitated, while molybdates and tungstens in acid solution give color reaction with rhodamine B, similar to those given by antimony salt. The freshly prepared benzene solution of rhodamine B is preferred to the aqueous solution. Benzidine, its structure is given in the margin in figure. It is a basic reagent and is employed in slightly acidic solution as dihydrochloride for the precipitation of sulfate as C12H12N2H2 whole 2 positive, SO4 2 negative. The resulting precipitates may be titrated against standard alkali. The important drawback of the method is the relatively high solubility of the precipitate in water and even more in dilute hydrochloric acid. It also precipitates in ions like phosphates and tungstates and give crystalline precipitates with a number of metallic ions such as silver, copper, cadmium, gold, zinc, etc. with CO and Ti. Benzide yields a blue coloration in alkali medium, which is an important spot test for the metal ions. Recently, benzide in dilute acetic acid has been employed as a spot test reagent for the identification of some platinum metals like osmium, iridium, and platinum. Cupron. Its structure is given in the figure. It is a white crystalline solid. It is sparingly soluble in water but fairly soluble in alcohol. It also exists in the form isomeric beta form. Cupron is used as a reagent for quantitative determination of copper, molybdenum, and tungsten. Alcoholic solution of cupron gives a green precipitate with ammoniacal solution of copper salt. Precipitation of other metals in ammoniacal medium is prevented in the presence of tartaric acid. The green precipitate is soluble in dilute mineral acids. Copper can be estimated both volumetrically and gravimetrically by this reagent. The green precipitate is an inner complex whose formation can be shown in the reaction. Cupron also precipitates molybdenum and vanadium ions quantitatively but is strongly acid solution. Vanadium gives a yellow precipitate while molybdenum gives a white precipitate. Tungsten and palladium also appear to be quantitatively precipitated with alpha benzoic oxide. Finger ETAL have recommended the use of the reagent for the detection of basicity in slightly soluble materials such as Al2O3, BaCO3, etc. Tenth is magnesium. The structure of this reagent is given in the figure. It is also called para-nitrobenzene resorcinol. 1 to 0.5% solution in 0.25 N in NaOH is generally employed in alkaline solution. It forms a bright blue lake with magnesium ions. The sensitivity of this test is influenced by the presence of ammonium salt, so their presence must be avoided. 11th is alizarin S. It is alizarin sulfonic acid whose structure is shown in the figure. It is a dye whose sodium salt is soluble in water and is employed as an analytical reagent. Aluminium salt gives a red precipitate with the violet solution of alizarin S in ammonia. This complex is the adsorption complex of aluminium with alizarin sulfonic acid. Adsorption system of this type containing metal hydroxide and a dye stuff are called lakes. Zirconium forms red-violet colored compounds with the reagent under the alkaline conditions. Boric acid also form brilliant red color in UV light by alizarin in H2SO4. The reagent has been employed as a spectrophotometric reagent for the above metal ions as well as for the few others. Furthermore, its applicability as adsorption indicator in the titration of FeCN 644 negative has been reported. 12th is nitron. Its structure is given in the figure. It is yellow solid. It is insoluble in water but dissolved in acetic acid. Its 10% solution in 5% acetic acid is generally used as a reagent. Nitron gives nitrate yields a sparingly soluble crystalline nitrate C20 H16 N4.HNO3 in solution acidified with acetic or sulfuric acid. Thus, nitron is a gravimetric reagent for nitrate. Perchlorate, perrhenate, tetrafluoroburate, and tungstate also forms insoluble salts and can be determined in a similar manner. Numerous other anions, including bromide, iodide, chlorate, thiocyanate, nitrate, and chromate, interfere but may easily be removed by preliminary treatment. The results in the presence of chloride ions are generally high possible because of co-precipitation. Salicyl aldoxime. The structure of this reagent is given in the figure. It is a white crystalline solid, melting point 57 degrees Celsius, sparingly soluble in water. 5% solution of aldoxime in 50% ethyl alcohol is used as a reagent. This reagent decomposes in solution and should not be kept for more than 3 days. Cydoxime gives a yellow greenish precipitate of the inner complex of copper with acetic acid solution of Cu2 positive ion. Thank you.